Welcome to the second half of the 4.5 notes. So we filled in this side together last time, and now we are on the next page. So we are going to write the factored form of a polynomial function that fits each graph. Remember that we're focusing on the zeros here. That's like one of the most important parts of the graph. So right here, we've got 3 zeros. And the most important part to notice about them is whether or not they are crossing through or bouncing. All of these, the line goes all the way through them, almost as if you were poking a needle through a piece of fabric. So really, I need to decide, okay, this one's at negative 1, 2, 3, 4. This one's right in the middle at 0. And this one's at 1, 2, 3, 4, 5. And what we're going to do is turn each of those into a factor. So the negative 4 will turn into x plus 4. It always switches signs because you want a number here that will add to 0 with this one. This one will just be 0. Doesn't matter if you put a plus or a minus. Either way is fine. And with the 5, we want it to be the opposite, which will be negative 5. The one thing I'm going to point out is that this technically doesn't need its own parentheses. What you can do instead is just leave it as x out front. And then x plus 4 goes next. And x plus 5, or x minus 5 goes at the end. And it does not matter what order you write these in. I'm just simply saying you could leave out those parentheses so it looks a little bit simpler. And then the last thing you need to do is check what's happening on the right side. It's going up. So that means this should be a positive number. So we can either leave it like this, or if we really wanted to, we could add a number. Like 3. Just randomly picking something. But you do not need that 3 to be there necessarily. Alright, moving on to the next one. Write the factored form of a polynomial function, I'll read you the directions again. Here's your zeros. And for today, we are only doing whole number zeros, by the way. So this one's at negative 1, 2, 3, 4, 5, 6. This one's at negative 1. This one looks like it's at 1, 2. And this one's at 1, 2, 3, 4, 5, 6. So we've got x plus 6, x plus 1, x minus 2, and x minus 6. And that's it, okay? At the very end, double check the right side. This one's going down, which means you need to put a negative out here. You can attach a number if you want to, or you can just leave it. This time, since I put a number on the last one, I will just leave it. And we will eventually do some equations where it wants you to actually multiply these out, but for right now, it says it wants the factored form. So we don't need to multiply it out. This is good right there. One more time, I knew I needed a negative out here because the right side is heading down, and the right side only goes down if there's a negative out front. Alright, let's talk about this very last one over here. Looks like we've got a 0 here and here. So this one's at negative 1, 2, 3. And this one's at 2. And then notice how the one at negative 3 doesn't go all the way through the x-axis. It sort of bounces off. That means that negative 3 is going to be a double root. So when I go to put it in its parentheses, x plus 3, always the opposite, I need to put a little 2 on the outside to show that it's a double. And then this one is going to become x minus 2. It does not get an exponent because it goes all the way through. We could put an exponent of 3 on it if we wanted to, because any odd exponent will go all the way through like that. And then I'm going to look at the right side. It is going down again, so I need a negative. You can either just put the negative like I did on this one, or you could add a number with it if you want. And then everything else we're going to talk about in this video happens on the graphing calculator. Okay, so if you are working from home, I would open this up on your Chromebook and maybe watch the rest of the video on your phone so you can look at both at the same time. Okay, so here are some more parts of the graph that we can find using the calculator. Something called the local min and the local max. These are the lowest minimum and highest maximum within a region. So the fact that it says local means it's not like the highest the graph can possibly go or the lowest the graph can possibly go. What those are going to be is like this point right here. The graph still goes higher over here, but this is the highest part of this area of the graph. It's sort of like a hill. This right here would be a local min because it's the bottom part, even though the graph technically goes down to negative infinity. We can also decide where the graph is increasing and decreasing using our calculator. I will also show you how you can find the zeros using your calculator too. And you can use this to check yourself. Just don't abuse the privilege of the graphing calculator because I still need to know that you know how to factor. In fact, I think you'll find that sometimes it's just easier to factor. So there are 4 main steps to this. 1, 2, 3, 4. I'm going to kind of walk you through all of them. The first thing is you need to type the equation into the calculator. So you're going to click y equals, which is the top left button right here. Okay, y equals. And then you're going to type the equation in right here. So right where it's blinking right now. One thing that you need to do before you can do any of this is make sure that none of these are highlighted. When they are highlighted, it looks like this. See how that's like bold? If that's highlighted, you want to go up till it's flashing, hit enter, and go back down. Okay, somebody might have messed with your calculator if it's not yours, if it's one we're using in the classroom. And then you're going to type your equation. So I'm going to go ahead and come down here and grab my first example right here in the bottom left of the screen. So it's 4x to the 4th power. Now, how do you get an x in this calculator? This button right here. Okay, it's the one pictured right here. Okay, and then we need to the 4th power. The power is this caret button right here. And then after you type the power, hit the right arrow so it goes back to normal. Otherwise, everything will be part of the exponent, and you don't want that. And I'm going to type minus 4x caret 3 minus 7x, oops, see, I just did it. Everything's an exponent right now, so what I have to do is I have to go back and hit delete, delete, delete. There we go, minus 7x, and then if you want for squared, you can just use the one diagonal up from the 7, because then you don't have to do the exponent thing, plus 4x plus 3. So make sure you have yours typed in as well. And then what you're going to do is click graph so that you can see the graph. Okay, graph is the 4th option, 5th option, very top right here. Okay, it says graph. My graph is going to be all funky, which is actually not a bad thing, because that means I get to show you what happens if this happens to you. So if you're looking at a weird graph that has really high, really low numbers, you have to change the viewing window. So if you can't see yours or you can't see all of it, what you're going to do is adjust the viewing window using the window button. Fancy that. The window button is right next to y equals. It's this one right here. And see, mine is all sorts of all over the place. Start with these settings right here. So you want it to go negative 10 and 10. X min and X max is saying, here's how far to the left and to the right my graph is going to go. X scale means it's going to go by ones. I would not change that unless you have a weird looking graph. And then you want the y's to go from negative 10 to 10 as well, by ones. So these first three lines are saying, here's my lowest x value, my highest x value, and it's going to go by blank. My lowest y value, my highest y value, and it's going to go by blank. I would not change anything else further down on here. Now, when I click graph again, look at that, I can actually see a picture of my graph. So it's kind of like a W right now, and you're going to pretend like there's two arrows here at the top, okay? So the first thing we're going to do is find the zeros, because that's the first thing on our list right here. And you're going to use second trace. So second is the blue button. Trace is right here, the next to graph. And you'll notice that it says calc above it. That's because this is where you can go to calculate things. So you can type in any x value and it'll plug it in for you. I'm going to go to 0. And this is a little weird because it's going to give you some directions down here. Up here is the equation that you typed in. So you can always double check it here if you need to. And you'll see that it says left bound. Left bound means that you need to go to the left of the 0 that you're looking for. Okay? So I'm going to start over here on the left. And I'm going to hit enter. And then it's going to say right bound. You have to hit enter to get it to say right bound. And then what I'm going to do is I'm going to pay attention to these y values. They're positive right now, and I'm going to wait until they go negative. Perfect. It's negative 0.9. So then I'm going to hit enter. It's going to say guess. Just ignore it and hit enter again. So I have a 0 at negative 1. And then I'm going to do the same thing. I'm going to go second, trace, 0. And it says left bound. But this time, I want to be to the left of the one right here. See how there's two right side by side? So I'm going to go back to where I was, here. Notice how my y value is negative. Now I'm going to go to the right until my y value changes signs again. Boom. Now it's positive. And this one's at negative 0.5. You guys are smart enough to know that that's negative 1/2. And then we're going to go find another one. Now you might be asking yourself, how many do we have to find? Well, this is a graph that does a little w, which means it's probably going to be an x to the 4th power. So we're probably looking for 4. One here, one here, one here, and one here. So it says left bound. I'm going to go to the right a little bit because I want to be closer to this one right here. But I want to make sure that my y value is still up there. Okay, I'm going to go ahead and call this good enough. And then my y value is positive right now. I'm going to go to the right until it becomes negative. Boom. So you want your y value to change signs. That's how you know you've actually gone to the right of your 0. If you're still not sure because this looks really close on the graph, hit right one more time. And you can really tell now that the 0 was here and I'm all the way down here now, to the right. Ignore the guess part, just enter again. Okay, and this is really small. It's hard to tell where exactly it's crossing. That's why you need the calculator to help you out. And then I'm going to do this one last time. Second, trace, 0. I'm already to the left of my last one, so I'm just going to hit enter. My y value is negative right now, so I need to go to the right until it's positive. Doesn't matter how positive. I can go crazy if I want. I'm off the graph now. Just matters that you're on the right side of this 0 now. Ignore the guess, just hit enter again. 1.5. Or 3/2. Then it wants us to find the local min. So there's actually 2 of them, here and here. those are your local mins because they're at the bottom of their area. So what we're going to do is the same way we found the zeros, I'm going to go second trace. Except for this time, because I want a minimum, I'm going to pick minimum. And I'm going to scroll to the left because it's going to do the same thing it did for the zeros. It's going to say left bound. So I want this one right here, which means that I want to be to the left of it. I'm going to hit enter, and then it's going to say right bound. Here it is right here. I need to make sure I'm somewhere over here to the right. See, I've clearly gone past it and the y values have started going up again. That's how you know you've passed it. If I go too far all the way over here, then it doesn't know which one of these two it wants to pick. That's why I can't go too far. Don't go too crazy with it. So basically I'm saying that it's somewhere in between here and here. And I'm going to enter twice. So my first minimum is at negative 0.78, negative 1. But this one has 2, because there's 2 bottom parts to this W. So I'm going to go find the other one now. I'm going to go back to minimum. Okay, second trace, choose minimum this time. And I need to get a little bit closer before I hit enter. Okay, so now I'm somewhere in the area of this one, but I'm just to the left of it, so I'm going to hit enter. And then I'm going to go to the right. My y values are going down. I'm going to keep going until they start going back up again. Like that. A little bit too far. Okay, so now I'm on the other side of it. And I'm going to hit enter twice. Because you don't actually have to guess. 1.28, negative 1. Okay? And you might be like, where is she getting this information from? I forgot to say this earlier, but it's giving you an x and a y value here at the bottom. And notice how it says minimum? That's how you know you found the right thing. It will always kind of remind you what you just found. And then we're going to find the local max, which is this one right here in between. Okay, there's a little peak right here in like the middle of the W. So I'm going to go second trace, but I'm going to pick maximum this time. It wants me to go to the left, so I'm going to scroll on over to the left using my left arrow button. Hit enter once I know I'm to the left of it. My y values are going to go up as I go to the right. I'm waiting for them to come back down. Okay, see how I've now passed the top of the hill and I'm coming back down? That means I'm ready to hit enter twice. And my maximum is 0.25. Because of this 9, this rounds to 0.25. 3.52. This 5 rounds that 1 up to a 2. Okay? And then the last thing that we're going to do is not actually in the calculator. It's going to be using our answers. I'm going to scroll back up for that for a second. Increasing is the x values over which the graph is increasing from left to right. Decreasing is the x values over which the graph is decreasing. Increasing always means it's going to be going this direction. Decreasing is always going to be going this direction. So up and to the right or down and to the right. So my increasing areas are going to be this part and this part. Even though it's really steep, these are my 2 sections that are kind of slanting upwards. Okay, if I go from left to right, it's going down, then up, then down, then up. When it's going down, that's decreasing. And when it's going up, that's increasing. Sorry, I know that didn't work super well. So I want this chunk right here in between the first minimum and the maximum. The x values of those 2 points are here and here. So that's from negative 0.78 to 0.25. And then there's another section where it's increasing from this minimum to the right, which is infinity. And this minimum was 1.28. I'm only focusing on the x values. And I know I'm slightly out of space. I promise you I made these bigger on the homework. And whenever we have two intervals, we put this little u in between them. The decreasing parts are like the opposites. So this first part right here on the left, this is negative infinity because the left side is negative infinity for x's. And then it stops right here at the first minimum, which was negative 0.78. And then it goes down again in between the maximum and the second minimum, which is going to be this number and this number. So we have negative infinity to negative 0.78, and then 0.78 to 0.25, 0.25 to 1.28, and 1.28 to infinity. So if we piece together all four of these, we get the whole graph back. It just has to stop at all three of these points. Okay. Let's do one more a little bit faster. So I'm going to type in this equation, negative 2 x caret 3, hit the right arrow, plus 19 x squared minus 56x plus 48. And then I'm going to hit graph. Dun, 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 dun. Okay, and it looks like it fits. I can see everything I need to see on there. It has a power of 3, which means that it should start going down on the right because it's negative in front, and go on the opposite side on the left. So if it's an odd power, that means that these two ends should be doing opposite things. If this was an even power, that means that it's either missing this part or this part, because they should be doing the same thing. Okay, so we're going to find the zeros first. Second, trace, go to the 0. It says left bound. It looks like I've got one here and one here. So I'm going to scroll over to the left. Okay, there we go. And actually, I'm going to kind of go back for a second. So I don't see my cursor anywhere on here. What you have to do is look at your x value. It says negative 0.2. That means you're right here. So we're like somewhere over here. That's too high on the graph because the y value is 60. We want the x value to become higher so that it moves over here in this area. So I'm going to hit the right arrow until I see my cursor again. There it is. I'm to the left of my 0, so I'm going to hit enter. Now it's going to direct me to find the right bound. So I'm going to go to the right until this y value becomes negative, until it changes signs. Boom. I'm going to hit enter twice. 1.5, or 3/2. And then I'm going to do this again. Second, trace 0. And this time my left bound is going to be for this one. Enter. And I'm going to keep going to the right. And my y value, is negative, so I'm going to wait for it to go positive. And it never does. See that? It goes from negative 0.009 to negative 3.3 again. So it's getting bigger negative and never went positive. That's good. That means that this is a double root and it actually bounced. If it had gone positive in between here, that means there's 2 tiny zeros in there. Okay, so now I'm on the right, and I'm hitting enter again. If it says guess, that means you still need to hit enter one more time. And we're going to go ahead and call this a 0 at 4. If there are that many zeros in there, it means it's probably at 4, but your calculator has to do a little bit of estimation. And then I'm going to write double next to that one because it's bouncing. It's always a good idea to note when it's a double root. Okay? And then I'm going to go find my local min. Guess what? There's only one this time. It's right here. So I'm going to go second trace, minimum, and I'm going to move my cursor to the left until it's on the left side of this point. Hit enter. It's going to direct me to find the right bound, so I'm going to hit the right arrow until it's on the right. Hit enter. It's going to tell you to guess. Just hit enter again until it actually says minimum, which is at 2.3. Repeating, comma, negative 4.63. That 9 rounds this to 6.3 instead of 6.2. Now I need to find the maximum, which is the top of the hill right here. Second trace, maximum. I'm to the left of it right now. And I'm going to go to the right until I get past that peak and my y values start going down again. It's going to tell me to guess. Don't worry about it. Just enter again. And it's 3.99999. That's 4, guys. And then I picked this problem for a reason. This is trying to say negative 2 times 10 to the power of negative 11. And what that means is it's negative 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Which is basically 0, guys. So whenever you see that E with a negative after it, that means that this is a really small decimal like that, and you can basically call it 0. Which makes sense, because we already knew that there was a point right there. It's our 0 right here. So that's also the maximum. Because it was a bounce, so it went there, bounced, and went back down. So whenever you get a 0 that's a double, it will also be one of these two also. It'll be a max if it's at the top of its area and minimum if it was at the bottom. Okay, increasing. The only part that's slanting up and to the right is this part right here in the middle. And that's in between the max and the min. So in between these two numbers right here. The decreasing part is from negative infinity on the left. Even though this doesn't actually cross over on the left here, it eventually would. You just have to go really high on the graph to see it. And then it's going to stop at the minimum, which is 2.3. And then it goes down again from the maximum to infinity. So from 4 to infinity. Like that. Go ahead and pause the video, try the last one on your own, and then I'll put all of the answers on it for you. Hey guys, welcome back. So, I've listed the 2 zeros for you here. One thing that happens with this graph that you probably noticed is that it looks like it's missing pieces. That's because we need to go further down. So nothing's really going on up here, so that's not the issue. We want our y values to go lower. So what I'm going to do is I'm going to go to Window, I'm going to go down to my y minimum, and instead of negative 10, I'm going to pick something lower, like negative 20. And I'm still just barely missing this middle part right here. So that means I need to go even lower. Well, still missing it, so I'm going to go even lower, except for this time I'm getting really fed up with it. I'm just going to go ahead and skip to negative 50. Now I can see the whole thing. And then I can do second trace 0, scroll over to the left, hit enter, scroll over to the right, hit enter twice. So my first 0 is at -4. And I'm going to do the same thing again. And it's going to round it a little bit because I'm so far zoomed out in order to see the bottom part. Okay, I'm on the left side of this 0, enter, going over to the right side. And I went really far this time, it doesn't really matter. I'm going to hit enter twice. And I'm going to call 0.999999 just 1. Okay? And both of those are bouncing. So they are both double roots, which is why I have only 2 zeros, but it's a 4th degree because both of them count as 2. And I have one local min, it's right here in the middle. So I'm going to go second trace minimum. Going to go to the left of it. Enter. Go to the right of it. Enter twice. Wait till it actually says minimum, not guess. So that's -1.50. So this 9 turns this into a 0 and this into a 5. It rounds this 49 up to 50. And then the y value is -39.06. And there's 2 local maxes. I'm going to save us a little bit of trouble right here. It's these 2 points that are the zeros. So guess what? I'm just going to say that I have a local max at -4, 0, and 1, 0. Because they were my zeros, I know that these were my x values, and the y value is 0. That's the whole point of finding zeros. If you want proof, I will find one of them for you. Maximum. Gonna go over very far to the left. See them over there. Hit enter. Go to the right. Hit enter twice. Make sure it doesn't say guess, but it actually says maximum. -4, 0. And I'll do the other one really quick too, just to let you see. Here's my maximum. I'm on the left, so I'm going to hit enter. Now it's saying to the right. Now I'm on the right, so I'm going to hit enter twice. And again, this just means 0.11 That's pretty much 0. And it is increasing here and here. So that's -infinity to this first one, which is at -4. And it starts increasing again from the middle at the bottom, which is the minimum, -1.5. And it stops going up here at the 1. Because again, I'm looking at the x values. So it's like right here, -1.5 to 1. My decreasing parts are here and here. So that's -4 to the -1.5. And then from the 1 to infinity. And I forgot to write the little u in between on the increasing. There you have it.